Hi, it's Tom, and today we're going to solve another popular coding interview problem called add two numbers. And in general, it's a pretty common and pretty easy problem, but in many cases, it uses a linked list, which makes it a little bit more sophisticated and allow us to verify if the person understands how linked list really works. So maybe start with the description. As usually, we're using LeetCode to get the definition of the problem, and then we'll go back to the whiteboard and try to solve that in JavaScript. So the description is pretty simple. You're given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contain a single digit. Add the two numbers and return it as a linked list. You may assume the two numbers do not contain any leading zero except the number 0 itself. So as we see, there's also an example which shows that how the linked list is presented. And as we see, the first element is the least important value. So if we start with 2 and then there's 4 and then there's 3, it means that the real value is 342 and so on. So maybe switch to the whiteboard and I'll try to explain you how linked list works and how we can solve this kind of problem. Okay, we are on the whiteboard, and let me quickly show you how the linked list works. So the linked list is a pretty specific concept in which each object from the list has a reference to the next one and only to the next one, which causes that there are some problems if you want to go to some particular object, because if you would like to go, for example, to the third object from the list, you cannot go there directly. You have to go to the first one, then to the second one, and then to the third one. There's no way to go from the first to the third and any other except going to the second one. That's pretty simple, I believe, but can be problematic in some cases. Okay, so maybe think about an example which we could use to implement our algorithm, and I prepared previously some example. Okay, it will be 42. Please keep in mind that the least important number is first in linked list. So this value has reference to the 2 has reference to the 4 and not to any other. And the second list might be 5, 6, and maybe 4. Why not? Okay, so this is very similar to the simple mathematics that you're being learned when you're young. So usually we would just add values from the columns, and that's exactly what we want to do in this case. So starting from the left, because these values are the least important and these are the only ones we have reference to. So we add the value from the first node and from the second node, and it's 7. That's okay, that's pretty simple. We create a node, and then we can go back to the next value. we have to add 4 and 6, and that's 10. We cannot save 10 because, as we all know, in this case we have to move 1 to the second, to the next position, and then save only 0 here. And in this case, in the last case, we are exactly here. We have the carry, the value from the previous column. We have no value for list number 1, and we have value 4 for list number for node from list number 2. So there's 4 plus 1 gives us 5. And we can go to the next column, and we have no carry, so it's 0. There's no value from the list 1 node, so it's 0. And there's no value from the second list, so it's 0. So it's pointless to add this 0. And basically that's how this algorithm works. And as a result, we have 7 leading to 0, leading to 5. That means that it's 507. And yeah, it looks like pretty good solution. So it's worth to remember that the result of this algorithm is only this node. This node, which allows us to go to the next one and the next one and all other that are there. Okay, so maybe switch to the code, and I'll show you how you can implement that in JavaScript. Okay, so we are in Visual Studio Code. I copied part of the code from the lead code, prepared some values to verify this solution, and yeah, we can start implementing the algorithm. So at first we need the carry, so we need a variable to keep carry. Yeah, the value is 0, and we also need a return node, which might be null as for now. And we might also need a reference to the last node to be able to update the reference to the currently calculated node. Okay, and then, as in the algorithm, we need some kind of loop which will check as long as there will be value in at least one list. Okay, so we could use while loop, and in while loop we will check if the element L1 will be not null, or L2, or carry will be bigger than 0, because there's also a case in which the list will be equal, and on the last position will be like 5 and 5. We have to add it, and even though there's no node in list 1 and list 2, there's still a carry that we have to save. Okay, so we can start counting to temporary sum and start with carry. If carry is equal to 0, it doesn't change anything. Okay, so if there is an element in list 1, we can add it to the sum. Okay, and it's not needed anymore, so we can assume that it will point to the next one. Okay, We can do that the same thing with the element from the list 2. So L2, and L2 will now point to the next node. Of course, if it exists. Okay, so we have sum, and we can save it as a new node. Yeah. So let's create a temp node, and it will be new list node. And remember that if the value of sum of the first node of the element of the first list and the second list and carry is bigger than 10, we just save the value modulo 10, because in this case we'll have to move the carry to the next column. So we can write it like that, and if the sum will be 9 modulo 10 is still 9. If it will be 19, it will be 9, and which is what we really want. And we can also update carry value right now, and the carry value we can use the floor function to save it. We can split sum by 10, and if sum will be 9 split it by 10, it's 0.9. Using floor function it will be 0. If it will be 11, the sum divided by 10 will be 1.1, and using floor function it will be 1. So that's exactly what we need in this case. Okay, and right now we have to save those nodes. So if we don't have last node and return node, yeah, if last node is null, this case will happen only just once at the first round of counting. We can set the temp value to be the last node. Okay, and we have to skip this reference, so return node will be equal last node. And in any other case, we want to set the last node reference, so the last node next value, to be the temp, the currently counted node, and we want to switch the last node to be the currently counted list node, so last node next. Yeah, I hope you get how this works. So through these lines we create a new list node which value is the sum of the value of the node from the list 1, from the list 2, and the carry, if there is any carry. And in this if else statement, the first case is only at the first attempt of the loop, so we wanna set the last node to be this particular node, because there's no previous, so there's no need to set next for the previous node to be the reference to the currently counted node. It's the first node, so we can set the last node to be the currently created node, and we want to save this reference to be returned, so we set the return node to be the last node. It's the currently counted node. And in any other attempt of the loop, we just set the reference for the previously counted node to be the current node, and as you see in this line, we set the last node because there's last operation in this loop. So the last node will be the currently counted one, and from the next round of this loop, we'll just create a new node and set the reference for the previously counted to the current one, and so on and so on. So the loop is complete, and yeah, now we just have to return the return node. That's it. Hopefully that will work. And yeah, as you see, I created two lists, exactly the same as we used on the whiteboard. So there's 42 and 465, and I used them to count the value, and because of it's a linked list, the result will be printed in form of the values one after another. So yeah, let's try if that will work. Oh, that won't work. Okay, I'm back, and to be honest, I stopped recording because I was a little bit confused what have happened, and it turned out that I was adding the objects to the sum instead of values, so that's some small typo I was unable to notify, and right now it should, yeah, it's working. So and the result is the first element is 7 referencing to 0 referencing to 5. That means the result is 507, and yeah, we checked that on the whiteboard and it works. So thank you for watching, and let me know what kind of problems would you like to be solved next time, and bye.